So today's lesson, we're talking about solving linear systems, specifically how they would arise in word problems. So there's basically three ways we can solve linear systems. We can use it by graphing, substitution, or elimination. So when we graph with the two lines in slope-intercept form, the equations are very straightforward. So graphing has the advantage of visualization, and the main drawback of graphing is that it isn't very accurate for solutions, and we're going to see examples of these. We can use elimination when variables can be easily added or subtracted, as from the last lesson. Or we can use substitution if one equation can easily be substituted into another, or if you cannot use elimination. So first example, we solve by graphing, right? So we have two lines here, y equals 2 over 3x plus 4, and then y equals negative 2 over 3x plus 12. The slope and the y-intercept of that first line, slope is 2 over 3, y-intercept is 4, and we have the red line here indicating what that line would look like on the graph. Our second one, our slope is negative 2 over 3, and our y-intercept is positive 12. So we have a blue line here. So when we go ahead and place that on the graph, we can see how that line would represent that equation. Visually looking at it, we can easily see the point of intersection, which would be, well, x is 6 and then y is 8. So the point of intersection is 6 and 8. So if we remember, graphing can be used in any format, not just our slope-intercept form. It may mean that you have to rearrange the equation to find the slope and y-intercept. So we have two examples here. So we have an equation, negative 2x plus 3y is equal to 12. Well, we can't simply state the slope and y-intercept from this format, so we got to change it around. So we can see here how we go ahead and isolate our y. So we divide everything by 3, and then we go ahead and make sure that it is on one side of the equation. So then when we manipulate this equation to isolate for y, we get y equals 2 over 3x plus 4, which we found up top. Another way, another example would be 2x plus 3y is equal to 36. Again, how do we get y by itself in order to identify the slope and y-intercept? Well, we isolate the term with the y, which we did, which is positive 3. Everything else goes the other side of the equation. The signs change if needed, and then divide everything by a factor of 3. Then we have our new equation. Y equals negative 2 over 3x plus 12. So our slope would be negative 2 over 3, and our y-intercept would be 12. Right, so if ever you see an equation, you can go ahead and rearrange it however you need to in order to find our slope-intercept form, which is then easily, it easily identifies our slope and our y-intercept. All right, second example, solve by substitution. All right, Samantha is looking for a banquet hall for her school's winter semi-formal dance. The first hall she calls charges a $1,000 rental fee plus $14 a person, while the second hall charges an $800 rental fee plus $16 per person. How many people must attend in order for the two halls to cost the same? What is the cost of the two halls at this point? So basically, you're looking for the solution of these. So if I go ahead and I underline the first hall charges $1,000. That's a terrible line. Charges $1,000 plus $14 a person. And then the second hall charges $800 plus $16 a person. So we can see how we have our first hall, which would be our blue. Oh, pardon me, which is our red. And our second hall is blue. So we can see here, if we were to write this as an equation with the variables x is the number of people and y is the total cost. For the first hall, well, it's $14 per person plus $1,000 as a rental fee. The second hall is $16 a person plus $800. So right there we have our two equations. And we can go ahead and solve by substitution. So if we remember that y is equal to 16x plus 800, or in this case as well, y is equal to 14x plus 100. So what we've done is actually we've gone ahead and we've set one side of the equation will be equal to the other. So we have 16x plus 800 is equal to, right, because that's the value of y, and this is another value of y. So when we set them equal to each other, we're simply solving for one variable now. So how we solve for the variable of x, well, I bring this 14x over, bring this 800 over, the signs change. We have 16x minus 14x is equal to 1000 minus 800. 2x is equal to 200, divide both by 2, so we have an x value of 100. So that means the number of people is going to be 100 people. Once we have a value, in this case our x value, we sub x is equal to 100 into number 1 or number 2, the first equation or the second equation. So we've gone ahead and used our second equation. Y is equal to 16x, remember x is 100, plus 800. 1600 plus 800 is equal to 2400. So what that means, if we were graphing at that point of intersection, the x value is 100 and the y value is 2400. So in terms of number of people and then total cost of the hall, 100 people must attend in order for the two halls to cost the same, and the cost of the halls is 2,400. So that would be when the halls cost the exact same. 100 people, and it's going to be $2,400. Third example, solved by elimination. So Daniela is selling tickets for Hamlet, a play being held at her school. The first week, she sold 13 adult tickets and 7 student tickets for a total of $165. The second week, she sold 26 adult tickets and 17 student tickets for a total of $345. How much does each ticket cost? So if X is the number of adult, Y is the number of student. So our first one, that first week, we have 13 adult and 7 student, and she made $165. That second week, we have 26 adult tickets, and 17 student tickets for a total of $345. So we're solving by elimination. Well, how do we eliminate these two? What we do is we take that first equation and how do we set one of the terms, either the y or the x term, so that it's the same as the other? Well, we can see here, we took equation 1 and we multiplied everything by a factor of 2. So 2 times 13 is 26, 2 times 7 is 14, 2 times 165 is 330. So now we have x terms that are the same, we have y terms, and we have our new constant term. These x terms eliminate because we're subtracting 17 minus 14 and then 345 minus 30. So we end up getting, well, these are gone, 17y minus 14y is 3y, 345 minus 330 equals 15. So now you have 3y is equal to 15, divide both sides by 3, we get a y value equal to 5. Now, we have a y value where we have a variable value, sub y equal 5 into either 1 or 2, right, the original equations. So if we use our first one, 13x plus 7y, we know our y value is 5, equals 165. Well, 13x is equal to 130. Divide both sides by 13, we get a value of 10. So therefore, each adult ticket costs 10, which we got here, X is adult, and each student ticket costs $5, which is right here. So the big takeaway would be looking at these word problems and just simply identifying what the information is and what it represents by stating our equation, and then going ahead and using whichever method is being asked of us, either by substitution or elimination, solve for one of the variables, and then plug in that variable value into the other equation to get the second variable.